At what speed the velocity head of water is equal to pressure head of 40 centimeter of mercury. So first we can find out what about the relation between pressure head of water and pressure head of mercury. That means for the same pressure, so let's say pressure exerted by the mercury column is equal to pressure exerted by this water column. So that if we are comparing this, we can write pressure is equal to H into rho into G. And for mercury, that same pressure is going to be exerted by some height of liquid column, take it as H into rho into G in terms of water. So this G is same in both the situations, so we can cancel it. And in this situation, it is given that 40 centimeter. So H is, we can take it as 40 centimeter or 0.4 meter. Density of mercury, which we can take it as 13.6 into 10 raised to 3, is equal to, we can take it as height of water column into density of water is 10 raised to 3. So we can find out what about the corresponding height of water column over here. So 40 centimeter of mercury column is having same pressure as that of H height of liquid column or water column. Then their height is 0.4 into 13.6, which is equal to 5.44. So the height of water column is 5.44. Then RM is to find out what about the corresponding velocity head. So velocity head, we know that the equation is v square divided by 2g. This is equal to 5.44. So you can write the value of v square is equal to 5.44 into 2 into g, which we can take it as 9.8. So the value of v will be equal to under root of this, around 106.6. So if you're taking the root of this, you'll get 10.32.